Take a look at this load of crap. No, literally, this landfill is a massive, stinky pile of garbage, and it's in our very own city of Ottawa. We rely on landfills to get rid of our garbage, but let's stop and consider what happens when we put our garbage there. Surely we don't just expect our problems to go away when we put them out of our sight. So our team is going to analyze the environmental impact of landfills. Like how exactly do they impact us? But why do we care about this? Let's turn our attention to Bella as she explains to us why we ought to care.
At the landfill, gases are formed and released into the atmosphere, ultimately contributing to global warming. Over time, the effects of this warming is causing more and more extreme weather events that many of you have experienced. Like, does anyone remember the tornadoes in May 2022? Or maybe the smoke this past week from the 160 forest fires going on in Quebec? The threats landfills pose also extend to the water you drink. Landfills create liquid waste known as leachates that can migrate into the groundwater and be distributed to your homes. The soil surrounding the landfill is also polluted by toxic compounds that may be taken up into the food we eat. I know this seems overwhelming, and you're well aware that the world is literally on fire, but we're not completely powerless. Technologies are being made to help reduce and reuse this waste. But in order for these technologies to gain the attention they need, we have to address the problems that need fixing. We hope through this presentation that you'll gain a better understanding of these environmental issues and that we can empower you all to demand better for your future.
Brandon will start us off by explaining the process of bacterial decomposition and how that leads to the production of landfill gases. Then I will explain how global warming emissions from landfills contribute to the greenhouse effect. Isabella will be explaining how landfill leachate pollutes our groundwater. And finally, Spencer will be explaining how landfills have an effect on our soil quality.
Let's think about the air we breathe for a second. What's in it? Well, thanks in no small part to landfills, there's little more methane in there than there was 100 years ago. The air we breathe, the air in the atmosphere, is ever so slightly changing due to the process of bacterial decomposition. So let's consider this engineering theory and how it produces these landfill gases and perhaps how we can mitigate the process. So what is bacterial decomposition? Now, even if you're someone like me and haven't the slightest clue about gardening, surely you know what composting is, which converts organic waste into useful food for plants. And this is an excellent example of bacterial decomposition. When compost is first deposited, it undergoes a process called aerobic decomposition, shown in the left side of the right picture. As you can see, it's not unpleasant to look at. There's plenty of room for everything to breathe, so to speak. And in this stage, aerobic bacteria, which depend on oxygen to live, consume all the oxygen present and release carbon dioxide. You can think of how humans breathe in oxygen and then breathe out a hot breath. When all the oxygen has been consumed, we're left with this gross pile shown under day 7. When this occurs, anaerobic bacteria, which do not depend on oxygen for survival, consume the waste sugars and produce acid for other bacteria to eat. These other bacteria, called methanogenic, are the end of the bacteria chain and they release methane. So you can essentially think of a landfill as a big, giant compost pile. Landfills contain large quantities of organic and inorganic material that are decomposing. And just as bacteria decompose compost piles, so too do they decompose landfills. And you can think of them either as that big compost pile or maybe a collection of a number of different smaller compost piles all together. And due to the sheer volume of matter present, landfills produce a significant amount of methane relative to other contributors. They're responsible for 23% of Canada's methane emissions and pose a significant threat to Canada's 2030 target emissions reduction. So we want as little as this in the atmosphere as possible. So after all this doom and gloom, is there a bright side? In other words, how do we stop this from happening? Since efficient decomposition requires oxygen, moisture, and high temperature, there's no current ways to prevent this natural process from occurring. However, several solutions have been offered to prevent the produced gases from escaping into the environment. The first solution is to simply put less waste into landfills. Less landfill, less emissions. In the early 2000s, some European countries reduced landfill disposal, and now they have lower methane emission levels today. And this is an attainable method for everyday consumers like you and me to take. A second solution is to reduce landfill emissions is to just collect and convert the gases into energy. Large biocovers can be used to cover the landfill and then collect gas. And this can be turned into cheap, clean fuel. So in conclusion, landfills produce gases such as carbon dioxide and methane through the process of bacterial decomposition. Aerobic and anaerobic decomposition produce carbon dioxide and methane. There are two viable options to mitigate landfill gas production. Firstly, we can just use less waste material and use recyclable material instead. And secondly, we can capture this methane and convert it into cheap, clean energy. Now, Basma is going to discuss why we don't want these gases in our atmosphere, why they're bad.
Hello, everybody. I hope that you guys are all doing well. As Brendan has explained previously, landfills produce a great amount of gases that negatively impact our planet. Today, I'll be explaining in detail how global warming emissions like methane and carbon dioxide produced by landfills contribute negatively to the greenhouse effect. Now, let's take a closer look at the two main carbon emissions that are produced from landfills. 90 to 98% of landfill gases are made of methane and carbon dioxide. As seen in figure 17, a methane molecule is made out of 4 hydrogen atoms and 1 carbon atom. And as seen in figure 18, a carbon dioxide molecule is made out of 2 oxygen atoms and 1 carbon atom. Since these molecules are made of 3 or more atoms, it allows them to stretch, bend, and twist in many different ways. That makes methane and carbon dioxide effective at absorbing heat. As a result, methane and carbon dioxide are also referred to as greenhouse gases that contribute to a process named the greenhouse effect. I'm pretty sure that as a student with a busy schedule, many of you like to make simple and quick meals like ramen. When making ramen, you first start by boiling water in a pot. And to make the water boil faster, a lid is placed on top. The water boils faster because the water vapor is getting trapped inside, increasing the temperature. This analogy is very similar to a process called the greenhouse effect. As mentioned previously, the greenhouse effect is a natural process that makes our planet livable by making the Earth maintain a temperature that is suitable for life. The process begins when the greenhouse gases, like methane and carbon dioxide produced from landfills, collect in our atmosphere. As seen in figure 20, the sunlight is able to penetrate the Earth's surface, and the majority of that sunlight gets absorbed by the land and oceans. And the remainder gets reflected back as infrared light that can be felt as heat. Some of that heat escapes into space, and the rest of that heat gets trapped in the atmosphere by the greenhouse gases that were mentioned previously, leading to global warming. So the lid acts as the greenhouse gases, trapping all that heat inside. Global warming has a devastating effect on our planet. Global warming can lead to forest fires like the one seen in Canada currently, which has an effect on our air quality, animals, and people. Global warming could also lead to dried land, which affects our soil and vegetation. It also has an effect on our water levels, since global warming leads to melting of glaciers, and that will affect animals living in these habitats. To summarize, landfills are able to produce harmful gases like carbon dioxide and methane, which can contribute negatively to the greenhouse effect. Next, Isabella will be explaining how landfills have an effect on our groundwater.
In this presentation, I will explain how landfills produce liquids known as leachates. I will also discuss how leachate pH changes over the lifespan of a landfill, how acids make toxic compounds more available through drinking water, and how pH can be used to identify groundwater contamination. The process of leaching is actually very similar to making a cup of pour-over coffee. As the water filters through the coffee, it picks up compounds that give coffee its flavor and color. The coffee then passes through the filter, leaving the solid grounds behind. The process in a landfill is very similar, but much less delicious. When rainwater travels down through a pile of waste, it picks up toxic compounds along the way and forms a solution known as leachate. This leachate can then travel down through the soil under the landfill and get into the groundwater. To explain the threats that leachates pose to water, I'll introduce you to a helpful theory called the pH scale. The pH scale is a measure of how acidic or basic something is. It ranges from 0 to 14, with 0 being very acidic and 14 being very basic. The pH scale is actually a representation of the concentration of hydrogen ions in a solution. So a solution with many hydrogen ions, like the one on the left, is known as an acid, while a solution with very few hydrogen ions is known as a base, like the figure on the right. The pH of a landfill changes depending on the age of a landfill. This is because over time, a landfill goes through 4 phases of decomposition, but the second and third stages have the biggest impacts on pH. In phase 2, when bacteria that don't breathe oxygen take over the landfill, they turn sugars into acids, making the pH decrease. Leachates made in this phase can be very acidic. In phase 3, these acids are then consumed by other bacteria who convert them into methane gas, causing the pH to increase and making the leachate more basic. One of the threats of acidic leachates is that acids dissolve metals. If these leachates get into the groundwater, they carry with them very high concentrations of metals that, when consumed, can lead to a variety of adverse health effects. If the contaminated groundwater becomes acidic, it can also corrode the pipes used to distribute water to houses, making the water even more polluted with metals. Monitoring pH can be helpful for detecting contamination. Wells nearby a landfill can be used to monitor changes in pH over time. Any sudden changes in pH can indicate contamination and can be watched to ensure that water is safe for drinking. In summary, leachates are made when water travels down through the waste and picks up toxic compounds. When these leachates become acidic, they can more easily be dissolved into water, making them more available for consumption. Monitoring the pH of water in wells near landfills can be very helpful for determining if a water source is contaminated. Now I'll pass it on to Spencer, who will discuss how landfills affect soil quality.
Right. So how many of you would like to eat a 4-course meal at your favorite restaurant right now? Now, here's the more important question. Would you still eat it if you had to eat the fork and knife you used to eat it? Yeah, no, I didn't think so. My subtopic that's derived from landfill pollution is soil quality and heavy metal pollution. More importantly, how the electrical resistivity of such soil has an effect on the production of food we eat and biodiversity as a whole. So I previously mentioned that the term electrical resistivity. Now, what does this mean? Now, to answer that question, I first have to tell you what electrical current is. An electrical current is the flow of electrons through a circuit, and it is this flow that makes a circuit does what it's supposed to do. Resistivity, on the other hand, is the ability to oppose a current flow in one direction. And a good analogy that I like to use with this is if you were to put a finger over the end of a hose, kind of like I have in this drawing here, your thumb will resist that water flow, and then your thumb acts as a resistor. A real-life example of this includes the little red lights you see inside your toaster. These are actually resistors giving off heat to your bread. Right, so what does this all have to do with soil pollution, right? Well, it comes down to something called heavy metal pollution. In most landfills, there tend to be a lot of heavy metals, which are poisonous to humans, that can leak down into the soil here. Due to the fact that heavy metals happen to have such a high resistivity level, these poisonous metals can actually be detected and measured using devices that measure electrical resistance, such as a multimeter. Once these heavy metals are contaminating the soil, this is where things start to get dangerous. You guys in high school likely know by now that plants need nutrients in the soil to grow. However, because there are so many heavy metals in this soil, these plants start to die. And when I refer to plants, this includes crops grown in the ground that we eat. For example, corn, see in this image here, wheat, carrots, all that stuff. So referring back to my resistivity explanation, the higher the resistivity in the soil, the higher levels of heavy metals exist in that soil. At the end of the day, the heavy metals from landfills that we as humans produce, like chromium and iron, which are found in forks and knives, are ending up in the food that we eat, which can cause many different health problems for us and many plants to die as well, which, if you ask me, is not something that should be ignored. At the end of this presentation, we all hope that each one of you could pull some valuable information from what myself, Bella, Brendan, and Basma have discussed here today. The effect that landfills have on the environment, including global warming emissions, landfill gases, water pollution, and soil pollution, all have very dangerous and very real threats to us and the environment. You as grade 10s are all very young, impressionable people who, like us, will determine whether or not these threats take action. So it's crucial for us to all understand these effects from landfills early on. We thank each and every one of you for your time and attention, and remember, protect Mother Earth.